Hello everybody, and welcome to this AESQ webinar. The subject of today's topic is 13004 Process FMEA, but with particular focus on how to apply it in a complex assembly environment. We've allowed 2 hours for it. We'll see how that goes, but we are going to be doing a sort of live demonstration of some of the concepts on how to apply this as we go through. So my name's Ian Riggs, and I'm the Quality Executive for Rolls-Royce Civil Aerospace based in Derby. And I'm going to just introduce the other people from Rolls-Royce who are going to support me in today's webinar. So a little bit of background on myself. I've been doing FMEAs now for probably about 35 years. Originally, I was in automotive, working for customers such as Ford, Land Rover, and General Motors. And back in the early 1990s, the whole topic of APQP, including FMEA and gauge R&R studies and those things, really came to prominence. And those customers, such as Ford, did a superb job of developing their supply chain in how to deploy these effectively. And I was lucky enough to go on a lot of those training courses and to get coaching directly from people, particularly Ford and Land Rover at that time. For the last 19 years, I've been in Rolls-Royce. And so I've made that change into aerospace. And again, we see that more than ever, those defect prevention tools are more and more important in our industry and starting to be adopted, really, copied from automotive by Boeings and Airbuses, etc., and flow down through the supply chain. So although we are probably slightly behind the automotive industry, we are quickly catching up. As far as AESQ goes, I was privileged to be one of the founding members of the AESQ more than 10 years ago now. And in particular, I was the team leader for developing AS13100 and 13003, which is the measurement systems analysis. And I'm also the team leader for RM13004, which is the defect prevention tools to support APQP, of which FMEA is a key fundamental, and in my view, one of the most powerful defect prevention tools there are. So again, I consider myself very privileged to be leading that group right now. Now I'll hand over to Harj, so Harj can introduce himself.
Yep. Good afternoon or good morning, everyone. My name's Harj Sanghera, and I'm a manufacturing engineer at the Assembly and Test Operation Plant at Rolls-Royce Derby. I've worked for Rolls-Royce for 2 years now. Within them 2 years, I've been working very closely with Ian to implement the RM13004 PFMEA standard in an assembly environment. And today, we just wanted to show you our key learning points that we feel will greatly benefit your business. So with that, I'd like to hand over to Steve.
Yep, hi everyone, I'm Steve Roebuck. I'm the Head of Certification and Quality Assurance for Assembly and Test Operations in Derby. I've worked for Rolls-Royce for 12 years now, working in various manufacturing and supply chain quality roles, obviously more recently in the assembly and test arena. I'm the current human factors deployment lead for human factors in assembly and test, and some of my previous experience prior to Rolls-Royce has been the aerospace supply chain around special processes and also in the pharmaceutical industry. So yeah, nice to be here today and a warm welcome to everybody on the call.
Thanks, Steve. So just a little bit of insight on who's on the call today. We've now reached just over 500 people have registered for this event. So clearly, I think it's a topic that is becoming really important within the aerospace industry, throughout the supply chain. And with the work that AESQ is doing to deploy 13100 and the focus on defect prevention and their vision of zero defects, hopefully that's one of the reasons you've decided to come along today. But there's over 200 organizations in 34 countries. So, as Steve said, thank you for those who've got up early to join us, and thanks for those who have stayed up late, as well as everybody else for joining us today. And just to give you a flavour of some of the companies that are on the call today, I've tried to put as many of the company logos on here as possible, but you can see we've got airframers, and we've got engine makers, and we've got all sorts of supply chain companies from around the world all with us today as part of this. So welcome, and with that, I'll hand over to Amanda just to tell you a little bit about how the session will run today and how you can actually interact with the session as we go through.
Hi, everyone. Thank you for joining us. We will be recording today's webinar. You will receive an email notification when this video is available, and it will also be posted on the AESQ website for free viewing. We do have all lines muted, but please use the chat function if you have any questions. We will also be launching some polls and quizzes, and we are going to test one out right now.
Okay, so Amanda, I just wanted to thank you for all of the organisation skills you've done in actually making this event happen. Without you, we wouldn't be able to run this type of event. So thank you for your patience in dealing with us and actually getting this webinar off the ground. So thank you.
Thanks, Ian.
As Amanda said, we are going to test out the technology. So the first question will be in the form of a word cloud. And we'd just like to understand, where are you dialing in from today? So hopefully, if Steve launches the poll, we'll be able to see that.
Hopefully you can see that on the screens. Yeah, we can see some faces coming through, which is great. Quite a wide range in cities and places here. Just give it a few more responses.
I've got a kind of blank look on my face because I can't actually see the poll on my screen. So I'm relying on Steve's body language to try and paint a picture of what the poll is telling us.
Yeah, it looks like a very global audience, like we expected. So yeah, going from Hucknall, which is not very far from here, to Buffalo, Mexico, Bangalore. So yeah, a real good spread today, and just good that the technology is working as well. So
okay,
that's good news.
So it is the first time we've tried out a Teams poll, so that looks good. So just to make sure that it's working, we'll ask one more poll question before getting started. So on this one, we're just interested to know what function you are actually in today. So we're trying to get a mix to see of who is joining us, what function they're from, that is showing an interest in FMEA. So if Steve, you could launch this one.
Yeah. Got the quality function taking an early lead on this one, followed by manufacturing engineering. A few designers, a few from operations, training, consultancy.
The quality still winning, Steve.
64% currently.
Fantastic.
How about manufacturing engineers?
27% hard, so you're not doing too bad.
But that's great. I mean, clearly there's a mix of functions on, as you would expect, because this is very much a cross-functional activity that we're going to be talking about today. So it's great to see we've got a mix of people on the call too. Okay, so with that, let's get started. Let me share with you exactly what we're going to cover today. So we're going to start with a short recap on 13004. There are several webinars already on the AESQ website. It gives a general overview of Process FMEA in 13004. This one today is going to really focus on the application in a complex assembly environment. As you can see from the picture, we make civil large engines in Derby, and working with Harj, we're going to share some of the key insights we've had from applying 13004 in this assembly environment. We're going to try and illustrate that and bring it to life with a practical demonstration. So Harj will lead us through that later on. And then when it comes to human factors, one of the things we've always had questions about is in a manual assembly environment such as ours, clearly it's quite easy to put down, well, it's the fitter's problem or it's an operator issue. We're going to share something we've looked at from a human factors point of view. And again, we did a webinar, Steve and I, on this last year, but we're going to answer a more specific element of human factors as related to Process FMEA and how we should deal with that, or how we recommend that could be dealt with. We've then got time for questions and answers. Towards the end, Steve is going to keep an eye on the chat as we go through. So please, if you've got any comments, any questions, keep adding it to the chat. Steve's key role when he's not doing the talking will be to try and collate those and give us some structure when we get to that section. And finally, I'll just give you a bit of a signpost to some other places you can get more information on this topic and on some of the other AESQ related issues with 13100. So just a reminder, there's two key documents that we are referencing throughout today. One is AS13100. So this was published in 2021 and flowed down by all of the aero engine manufacturers to its supply chain, as well as adopted internally by its own operations as well. And within that standard, we look at the mandated requirements. So in Chapter C, you will see a lot of defect prevention tools where, in particular, FMEA is called up in one of the appendices. There are some very specific mandated requirements in there. To support the deployment of those requirements, we've also published a reference manual, 13004, which is available free of charge to download from the AESQ website. And that contains lots of really useful information from all of the aero engine manufacturers and members of the AESQ on how to deploy these effectively within your business. And just to point out that this was revised at the end of January. So if you downloaded a copy from 2023, there is a revised copy that you can download now since the end of January on the website. And the details are shown on the slide too. Okay, so just to recap on some of the key fundamentals from 13100 and 13004. I'm just going to cover a few key slides to try and summarize why 13004 may be different to how you would have done FMEAs in your company before. Just to start off with that, I'm going to hand over to Steve again, who's going to run another quick poll just to try to assess what mix on the call do we have, how many experts we have, and how many are learning about FMEA for the first time. Steve,
so hopefully you can see that poll now. If you'd like to submit an answer. So it looks like we've got a good mix of people on the call, which is good. So we've got some subject matter experts, so that's really positive. People who are leading the PFMEAs, people being part of the team. Probably the biggest percentage is people have been trained but not used it much, so hopefully we can give you some good learning on this call. and 12% with no experience, but they are curious. So,
Okay,
yeah, a good mixture there. So thanks for the response on that one.
excellent. Okay, so just to kind of calibrate ourselves with what is different about 13004. There's a number of requirements in AS13100. I'm just going to focus on 4 of those, which are really pertinent to today's discussion in the assembly environment. So the first one, it says it must be done by a cross-functional team. And I'm really pleased that on the earlier poll, we've got representatives from all of those functions you'd expect to be involved, whether it's quality, in particular manufacturing, engineering, design, etc. So one of the things Harj will touch on later is fundamental to the success of this approach, particularly in an assembly environment, is how do you get lots of different voices with lots of different experience and insights into what we're trying to achieve involved in creating the FMEA. The other one, which although I've done FMEAs in lots of organizations, the one thing that really came home to me in this assembly environment is about making sure the PFMEA is done at the right time in the advanced product quality planning process. Because when I look at a lot of the issues we have today, a lot could have quite simply been resolved if we had designed the part differently at the very start. So, for instance, mistake proofing components so that you can't fit them the wrong way round, or using the use of standard bolt sizes, etc. So you haven't got all of that variation on an engine. Those things can only be done at the design phase. And what I think we've seen in the past, and what a lot of our suppliers tell us, is that in many cases the design phase is done first and then it's handed over to manufacturing engineering to look after the process. Where actually you want, and APQP actually shows this, the process FMEA starts pretty much at the same time as the design FMEA, so that you're able to have that discussions and the feedback into the design process about how to resolve issues and how to mistake-proof issues before they are built into the design. So in this assembly environment, and Harj will again come back to this later on, absolutely critical that we can get involved really early in that process and have an input into design. The other thing that we're going to focus on today is around the failure modes, and the importance we place on it in 13004 about failure mode should be describing product defects, not process defects. And I'll touch on it on the next slide, but one of the common mistakes we saw when we were reviewing our process FMEAs was we were getting those mixed. And so some of the focus that we needed to try and prevent product defects happening was lost as a result. But then finally, it's obvious, but we do FMEAs for a reason, and it has to be to drive actions to remove risk and have a part of our journey to zero defects is through the work we'll do around PFMEAs. It's a live document that they are continuously updated as we make further improvements. But too many times we've seen companies put FMEAs in almost to tick a box in the PPAP file to say, yes, we've got one, but it's not actually there to prioritize and drive actions to make the process better tomorrow than it is today. So one of the key things, and again, Harj will touch on how we've done it in our plant, but how do we make sure that it gets the visibility and the traction to actually drive actions and improve our performance. So the other key slide that we found useful when we've been training this out is the actual template. And And we've divided it up so you can see the bits that are supposed to talk about the product. That's in the purple, sections 1 and 2. The bits that focus on the process, sections 3 and 4. And then the risk and the improvement actions, sections 5 and 6. So this was a real key learning point, I think, for our manufacturing engineers within Rolls-Royce, is to make sure that when we start off in sections 1 and 2, we're only talking about product requirements, product failure modes, and the effect of that to our customer. So clearly, we're looking at every process step. As part of our zero defects journey, we used to get questions, well, why are we doing every process step? Why aren't we just doing it on the important process steps? And the answer to that is twofold. Is one, you will only get the benefit of this defect prevention tool where you apply it. So if you don't apply it to all your processes, you will always get surprises. And that's what we were finding in our analysis. Where we applied it, we weren't getting the escapes and the rework, etc. Where we hadn't applied it, that's where the pop-ups and the surprises kept occurring. The second one is more about the product attributes that you're trying to achieve. Everything that's in the design that is defined as a requirement needs to be in your FMEA. So having that clear definition of, we want to make sure that there's a traceability back to the design process to your process is absolutely key. So we would use not only the engineering drawings, but the related specifications and assembly instructions. And one of the things to focus on the assembly instructions, as Harj will show you later, there's a really key learning point there that we've got to be aware of, that they should be treated or handled with a bit of care to make sure we only take out of the assembly instructions the bits that really help us develop the FMEA to be focused on the product. Section 2, we're looking at, well, if you know what you're trying to achieve through the definition and requirements, how could that go wrong? And simplistically, a lot of that is just the inverse of what's in the requirements. So if the parts need to be, as in this example, damage-free, then one of the failure modes you could have is, well, actually the parts end up being damaged. So it's really important, again, that the failure modes are describing product non-conformance, not process non-conformance. Then when we get to the effects, what would happen if it went wrong? A lot of our FMEA is focused on the internal things. So does it end up being reworked? Does it end up in scrap? Part of it was opening up the scope of that. So we are starting to look at what would happen to the engine when it's in service, when it's flying around, when it's done 2,000 cycles. If it had this failure mode, how could that show up to the airline? How could it show up to the airframers, so the Boeings and the Airbus? How might it show up there? As well as how could it show up internally in the next process, etc. So when you're doing the severity scoring, you're taking into consideration all of those things. Because in particular, if you've got a safety issue that might happen and cause an in-flight shutdown in service, you want to be able to prioritize that correctly when you're looking at it through the FMEA. In section 3, we started to look at process. So somebody once said something as part of the training that they thought because it's called a process FMEA, that section 1 and section 2 is focused on the process. That is not the case. It is still a process-focused tool, but the process focus comes in section 3 and 4. So now what you're trying to do is say, well, if I know what the requirement is and how I could get that wrong, section 3 looks at, well, what could cause it to happen? What would have to go wrong in the process to cause that product defect to happen? So that would be listed under your potential causes of failure. And typically there are multiple potential causes of failure for every failure mode. You then want to establish, well, what activities do we have to prevent that cause of failure from happening? And in some cases, there will be nothing. You are relying totally on the operator and the training, etc., to do that. But what you're trying to force out here is where there are no prevention controls, that is a key area for you to focus on in terms of improvement. But then occurrence score, how likely is that to actually happen? In section 4, you're looking at how are you going to detect if either the cause or the failure mode happen? How will you find that? And how likely are you to find it? And then finally, that will allow you to give you your risk priority number, and using your analysis of the high severities first and then high severity times occurrence, you can start to prioritize a list of improvement actions that you need to implement. So I think it really helped when we started rolling this out, both in Rolls-Royce and across our supply chain, to understand each of these kind of sections on the Process FMEA template. The other thing that seemed to resonate with people is just understanding how the columns link. So there is a logic flow that we need to make as we go left to right on here. So you can see that the requirement says parts to be damage free. The potential failure mode is linked to that. So it says, well, parts could be damaged. If you had a damaged part, what would the potential effect be and what would the severity be? But then when you get the potential causes, they're linked back directly to your potential failure mode. So what could cause that failure mode? And as you can see on this example, we've got 3 potential causes that could make that failure mode occur. What are our prevention controls, and what is our occurrence? But then under detection, we are looking at detection of the failure mode, but also detection of the potential cause happening. But then that allows us to give us a detection score and calculate the RPM. So one of the things we found is we often had causes that weren't linked to a failure mode, or failure modes that weren't linked to a requirement. So testing the FMEA just to make sure these links are there is really important. Okay, Steve, so one more poll then. So just another bit of insight from everybody on the call of who actually leads Process FMEA deployment in your business. Steve, if you can open that.
Yeah, hopefully you can all see that one again. Bit of a two-way race here between quality and manufacturing engineering, I think.
More manufacturing engineers.
Where's it ended up, Steve?
So we've got 50% manufacturing engineering,
Okay.
43% quality. Then we've got a few around design, operations teams, and project management. So
okay. Okay, and certainly in Rolls-Royce, we would look very much to manufacturing engineering to be leading our process FMEAs. But quality, design, operations have such an important role to play in getting a good quality process FMEA out. In the early days, within Rolls-Royce, it was very much a manufacturing engineering activity. And part of the learning initially when we deployed this standard was to make sure that all of the other functions who had an input were invited to the table to take part in its development. But it certainly in the old days wasn't the way that we used to do it in Rolls-Royce, and it's been one of the key changes over the last few years that we've got all the right functions with all the right training to be able to take part and contribute to that FMEA. Okay?
Yeah.
Thanks, Steve. Okay, so that's the recap of 13004 completed. I'm now going to hand over to Harj, who's going to share some of the insights with how we deployed this in our assembly environment.
Yeah, so the key message here again is just be careful when using assembly instructions to define the assembly PFMEA requirements. If you go to the next slide. So This is probably a very basic training example you see from a machining PFMEA. And the reason why we use machining PFMEA requirements is because it can be derived, the requirements can be derived straight from the engineering drawing and specification. So if we look to the left-hand side, we can see the drawing with the dimension and tolerances, and below it we can see the specification. And as you can see, this flows nicely into the requirements column on the FMEA, which gives us the correct potential failure modes. But assembly PFMEAs can be a little bit more trickier. So here we've got an assembly process with 10 steps. Prior to deploying AS13100, the common practice was taking each line of the operation text and putting that into the requirements column. So not only was this the incorrect approach, but we ended up with hundreds or thousands of lines of PFMEA lines, and you ended up just not getting anything beneficial to your business. And the main point that we found was that we wasn't conforming to the AS13100 standard, as we were focusing on the process and not the product. So when we actually focus on the product, we can only see that 3 lines are actually applicable. And here, now because we focus on the product, we have the correct requirements, and now we have the correct potential failure modes. Now we're going to go into more depth on the failure modes when we do the live demonstration. So now that we're focusing on the product, you see how this can greatly reduce the size of your PFMEA, and again, we're keeping it more focused on product conformance rather than the process. Next slide. So even though we've defined the product requirements from the assembly process instructions, it's not necessarily that the other steps are now redundant, but you could use these as a prompt to identify some potential cause of failure and even some prevention and detection controls. So you can see we've listed some examples for you to use as a training example.
Okay. So one of the other things that really helped and what we're going to use today as part of the live demonstration is, if you imagine in a environment of aero engines, we've got 30,000 parts, 6,000 operations. It can feel quite overwhelming to say, well, how are you going to step through such a huge beast and actually do a FMEA and all of that? But what we quickly realized is when you break it down, when you're trying to fit part A to part B, only so many things can actually go wrong. So in this example, we boiled it down to sort of 8 standard failure modes that we could use as a prompt when we were developing the FMEA. So you've got on here, part not fitted, wrong part fitted, parts misaligned, incorrect orientation. This is what we found, that in most of our assembly operations, these could be reused and kind of gave us a structure that the team could use to be consistent with how it was approaching the FMEA. Now, clearly, there are some that this doesn't capture everything. So, for instance, there are some of our processes where we're applying sealant that would have maybe a different set of standard failure modes that we would use. But for this particular example we're going to show with you today, these are the standard failure modes that apply. And for most of our processes, actually, when you look at the failure modes that would apply to those operations, I'd say in 80% of the cases, these will be common. It also helps to validate the requirements description. So let me just explain that. So we talked earlier that there needs to be a link between the requirements and the failure modes. And And you can see, so we've got assemble inlet part number in 1, and then the converse of that, so the failure mode would be wrong part fitted. And one of the causes for wrong part fitted could be that the part was mislabeled. So these things connect. It might be, it's talking about alignment markings and bolt holes should be aligned, so the failure mode is part misaligned, and orientation. So you can see from this example that 4 of the 7 standard failure modes are relevant. But you can see there's some that are not called out on here. But what we found, and what we found was really useful, actually, because we had these standard failure modes, you could say, well, damaged part was one of them. Are we sure that damage isn't important to this operation? And what it had highlighted in a lot of cases was actually, yeah, damage is important to this operation. It's just not included in the requirements. So we've had to go back into the requirement statement and include a requirement around damage or specifications. And 2 of the key ones for most assembly operations actually were damage and FOD weren't always included, but damage and FOD was always a potential failure mode that we would worry about. So by using the standard failure modes, we found there's been quite a few times it will allow us to go back in and refine our requirement statement to make sure that it's captured everything we needed to capture. Clearly, there are times when there's something on a standard failure mode that is genuinely not applicable, and therefore, you don't need to include that in the FMEA. But it is there as a prompt for the team to say, well, yeah, are we sure this doesn't apply? And if it doesn't, don't put it in. But we found that to be really useful in developing the FMEA and making sure that it was fully complete and an accurate reflection on what the requirements for that product actually were. Okay, so the next poll is slightly different. It's a bit of a quiz. So just to test out our understanding of 13004, it does kind of lead back to something we have talked about on the call. The question, this one is, which of the following is not a good example of a potential failure mode as defined by 13004? So there is a right and a wrong answer to this. So Steve, do you want to launch a poll?
Just want to check you're feeling okay, because you've gone very purple on the
camera.
See if you've changed now. Yep, you're better now.
We've got quite a lot of people going for the third answer. Torque wrench is out of calibration. Gone down a little bit now, but I'll probably get a bit of a clue there. But for a few more responses.
Is there a clear winner, Steve?
The clear winner is torque wrench out of calibration, but we have got a few around the first answer as well, around tooling left in the engine causing FOD.
Okay.
But yeah, torque wrench out of calibration is definitely the top answer.
Yeah,
so,
and that's the right answer as well. So clearly torque wrench out of calibration doesn't describe a product non-conformance. It may lead to a product non-conformance, and that's why torque wrench out of calibration may well appear in a potential cause of failure, because it's describing a non-compliance of a process, not of a product. So that's kind of the way of trying to keep those two things distinct. If it's, the item number 1, tooling left in an engine, if we did dispatch that engine to the customer with tooling left in it, that would be a product non-conformance, because that product shouldn't have tooling left in it, and it could clearly lead to a safety issue for the customer. But the torque wrench out of calibration, yeah, absolutely, that is a tooling non-compliance, not a product one. Okay, good. So we're going to change gears a little bit now, and now we're going to head into the practical demonstration of Process FMEA in an assembly environment.
Yeah.
So, Harj?
Yep, so we'll give a little bit of a insight of what we're going to do for the practical demonstration. So, example here, we've got an inlet and an outlet. So what we're going to do is we're going to assemble the inlet and outlet, making sure that it's the correct orientation. There needs to be no FOD or no damage, and then we're going to align the parts using the white mark that you can see to make sure the valves align correctly. We're going to fit 8 bolts, and then we're going to torque it to a specified value, and then we're going to torque it to the sequence as shown on the screen. So now we will move on to the live demo. Okay. Right. There we go. So what we're going to do is here we've got the inlet and we've got the outlet, and we've got 8 bolts here. So using the instructions that we had where we're going to assemble the parts, fit 8 bolts and torque them, we're going to use the standard failure mode list that you can see here and work down to show you putting this methodology into practice. So the first standard failure mode here is part not fitted. So if we would not fit the inlet to the outlet, we can safely say that it will be a little bit silly not to fit them. And again, in your business, there's going to be some blatantly obvious items that you physically will be able to detect when in your assembly line. So wrong part fitted. So if we look here, we've only got one variation of the inlet and outlet. So this standard failure mode here is not applicable. Part misaligned. So unfortunately, due to a poor design choice, even though we can align it like this, we can also align it like this, and the bolts will go through each of the holes as shown. So this standard failure mode is applicable. And again, incorrect orientation. So due to a poor design choice, even though I can orientate it like this, I can also orientate it like this. And again, unfortunately, the bolts will still go through the holes as shown. So damaged parts, there could be multiple causes of failure for this. So we could drop the inlet or the outlet onto potentially a hard surface. So this could cause damage to the internal or external surfaces. Again, we could aggressively assemble these parts together, causing damage on, again, the internal surface of the outlet and the inlet. And even when we're trying to align the white mark together, we could cause damage in the internal surfaces, again, on the outlet and the inlet. So FOD present, the area that you're working in may not be particularly clean. So FOD could end up on the internal surface on the inlet or again on the outlet. So when we do put these parts together, we could have an instance where the FOD stops it from being clamped down, or it could even cause damage again on the internal and external surfaces. And 7 and 8 are not applicable as we're not at the torque stage yet. So now we're going to fit 8 bolts. Here's an example I did earlier. So we fitted 8 bolts, and again, just so you can see from the misalignment example here, we can see that in practice. So all the bolts are fitted, and we still have that misalignment causing this valve to be misaligned. So again, now for the bolts, we're going to run through the standard failure modes again. So part not fitted. So it is possible for me not to fit a bolt in this situation. And again, wrong part fitted. So if you look at what I have, I only have one variation of bolts. So again, we can safely say that this failure mode is not applicable. So part misaligned and incorrect orientation. Well, if you see how the bolts are, simply cannot get it misaligned as it goes through the inlet and the outlet. And incorrect orientation physically cannot orientate this bolt in any other way. So I can't go through this way, or I can't go through this way. So 3 and 4 are not applicable. Damaged parts. So the way these bolts have come, as you can see, they're all together. They're all hitting each other. So we have metal on metal contact. So the potential cause of this could be damaged threads with metal on metal contact. And again, FOD present. If we look at how the containers actually come, we can see that there's a lot of FOD in there that could again get trapped in the threads and cause damage further down the line. And again, 7 and 8 are not applicable as we're not at the torque stage yet. Right, so let's torque these bolts up. Here, I have a standard torque wrench, and the only failure modes that will be applicable for this one would be damaged part, incorrect clamping force, and uneven clamping force. So damaged part, potential cause could be I could use the incorrect socket head, which could cause damage on the bolt, or I could even cause damage to the part as it could hit the inlet tube. So incorrect clamping force, even though I have a specified value in the instruction, I have the freedom to change this to whatever I want. So I could change it to too high or too low with minimal detection. And again, uneven clamping force. So even though we showed on the instructions that we were supposed to go this way, it doesn't really matter. I could go any particular way I want, and it could cause an uneven clamping force with minimal detection. So that's the first scenario. As we know, a lot of businesses don't operate with a single assembly product. So let's add a little bit more complexity to this now. So here we have the original inlet and outlet, and now we've got a different part with range bolts. So again, what we're going to do is run through the standard failure modes and see which ones are applicable now. So again, part not fitted is the same as scenario 1, where it would be a bit silly if we didn't fit the inlet to the outlet. And ROM part fitted, now this standard failure mode is applicable because I could fit the original inlet, but I could also fit this inlet. And again, it will still I could be able to put all the bolts through as per previous. Again, all the other standard failure modes that we discussed in scenario 1 will be applicable for this. So let's move on to the bolts. So move these out of the way. So here I have the original one with all the bolts fitted. So again, part not fitted is still applicable, as I could potentially not fit a bolt. However, ROM part fitted now, because I have a range of bolts available on the line, and they all have the same diameter, I physically can fit a different bolt. So here we have an example of bolts too long, and as you can see, this could potentially get detected because we can visually see the gap. However, in more of a dangerous circumstance, here we have a bolt too short. Now, this bolt can go through the inlet and lock on to the outlet's captive nut. But the issue here is that when these can still be torqued up, and potentially over time they could vibrate out, causing catastrophic failure. And again, the other standard failure modes are still the same and applicable as they were on scenario 1 and even the torque example. So what we're going to do now is we're going to implement some improvements. So we've gone back to the drawing board, and here we have a new inlet and outlet, and we're going to improve our packaging system now. So now, totally different scenario. So let's run through the standard failure modes again and see which ones are applicable. So just as scenario 1 and 2, part not fitted is still the same, so we can rule this out as not applicable. Wrong part fitted, so we've segregated the line now where only the specific parts will come to the line. So now this standard failure mode is not applicable. So part misaligned, thanks to some error proofing, now we can only align this one way. So if we were to align this way, due to an offset bolt position, if we were to put the bolt through here, we physically cannot fit the bolt anywhere else as they would stand proud. So now the only way possible is to align it like this. So we've error proofed that. So now this standard failure mode is not applicable. Incorrect orientation. So again, here, what we've done is we've increased the diameter and when we've increased the length of the inlet tube. So the only way we can orientate it now is like this, because if we orientate it the other way, as you can see, we physically can't. So 3 and 4 are now not applicable in this scenario. So damaged part, a potential improvement, what we could do here is we could implement a matting system. So if we do drop the inlet or the outlet, it won't cause damage to the inlet or the outlet. And again, with FOD, we can improve our 5S processes to ensure that no FOD is captured on the internal surfaces of the inlet and the outlet. So again, we're not at the talk stage yet, so we're not going to discuss 7 or 8. So let's move on to the bolts. So here's one added earlier. And again, let's run through the standard failure mode. So part not fitted, again, I could potentially not fit a bolt, but because we've improved the packaging system, we can sort of see now that we can account each bolt in this new packaging method. Wrong part fitted, so we've eliminated the range of bolts. So now we only have the specific bolts being presented to the line. So now this is not applicable. And again, as discussed in scenario 1, 3 and 4 physically aren't applicable because we can't misalign the bolt and we can't orientate this bolt incorrectly, so it won't go through here. Damage part and FOD, so what we've introduced now is a new foam system. So here you can see the threads are nicely protected now and they come in a presentable packaging method. And now moving on to the torque part now. So originally we had a normal torque wrench. Now what we've done is introduced an intelligent torque system. So incorrect clamping force now, what I have is a program controlled torque wrench where physically cannot change or adjust the torque value as it's programmed specifically to this. So now this standard failure mode is not applicable. And again, uneven clamping force. So even though this torque wrench does allow me still to work out sequence, some improvements and some solutions that are out there is we have proximity torque wrenches where it won't allow you to move out of sequence, or we could potentially have a tool that comes down and torques all these bolts up at the same time to give that correct even clamping force. So that was a live demonstration. We hope you found it helpful, and now we will continue with the rest of the presentation. So Ian.
Okay, thanks Harj.
No problem.
Thought there might be a few more reactions there, Harj, but yeah, well done on that one, mate.
Okay, so let's go back to this. Is that sharing?
Yeah.
Okay, so if you want to just recap what you've gone through in the demonstration, Harj.
Yeah, so again, just going through the standard failure modes that we spoke about. Here we've got a couple of illustrations as well, just to help you out. So going through the first one again, part not fitted. We used the example of, missing a bolt out. Wrong part fitted, so when we had two variations of the inlet, so it could possibly happen. Part misaligned, so due to the poor design on the first one, we could misalign the white marks, and again, all the bolts could be put through. Incorrect orientation, so again, like we discussed, we could orientate it one way, but it would fit the other way when we orientated it. Damaged part, so here we have the example where the valves actually come out, but we discussed examples of dropping the part or aggressively assembling them together and scratching the internal surfaces. And again, FOD, we spoke about a potential environment not being clean. So here we have an example where FOD could creep up, causing that damage. And again, incorrect clamping force where we could set it too high or too low. And the image we've shown there is if we do set it too high, we could crack the inlet. And again, uneven clamping force. If we don't follow that sequence, we could end up with one area higher than the other. And then just touching on some of the improvements that we did, if you remember. So for the orientation, we increased the diameter and the length. So effectively, what this did was we cannot orientate it in any other way. And again, with the alignment, as you can see from this demonstration now, if we were to not align the white marks together, we physically cannot put the bolts in because of that offset hole. And I think it's worth mentioning here that error proofing of parts must be done in the design phase. And in APQP, the PFMEA starts at the design concept so we can influence the design process. So other things that we did as well, we introduced some ITT, and we also reduced the risk of our C-class parts. So again, we removed all the parts that are not applicable to that product, and we introduced some new packaging to protect the bolts. Thank you.
Okay, thanks, Harj. So one of the things, just to show how that would, how it would look using the standard FMEA template. So if you take the requirement that Harj took us through, and we say, well, clamping force is one of the failure modes that we have. So in this case, we'll pick on clamping force too low. Now, if the clamping force was too low, our design engineers have informed us, well, that could lead to excessive vibration in service, which may result in a loss of thrust and consequently an in-flight shutdown. So that is quite severe. They've scored it on a severity level as an 8. So having the clamping force too low is a significant thing that we need to focus on. So what could cause the clamping force to be too low? The team have decided, well, you could have it under torque, so we haven't torqued the bolts enough, or indeed we haven't actually torqued it, so they've been fitted hand tight, but they haven't been torqued to the full value. The other one they've identified is that you could have an undersized bolt fuse. So in this case, imagine it's too thin. So it's actually been fitted, it's holding, but under pressure that could easily fail. Now, when we looked at prevention, for the under torqued and not torque, we've said, well, if we use intelligent torque tightening, that system will tell us and look for confirmation that we've actually done every bolt to the right value. So you can't not torque it because it won't allow you to progress to the next operation. You can't under torque it because it's set and defined by the system. So that intelligent torque tightening makes the chance of it happening very, very low, and it's been scored as a 2. In terms of detection, that intelligent torque system will also form, so if it was that criteria wasn't met, it would tell you and you wouldn't be able to proceed. So it's kind of mistake proofing your detection system as well. Hence, you end up with a relatively low RPN number of 64. Now, the undersized bolt, using the wrong bolt, this does rely on part kitting, which, a kitting process reduces the risk, but it doesn't eliminate it. So as a prevention control, it improves it, but it doesn't guarantee that it can't happen. So in this example, the occurrence is going to be slightly higher as a result. and you are relying on the operator checking at the fit and operation that he's actually got the right bolt and he's actually, it's been fitted correctly. And from that point of view, it's very heavily reliant on the operator. So that would score higher on a detection and hence a higher RPN number. So that just comes to show, from the example that Harj talked us through, that's how you would bring it down into the FMEA format of the template and end up where you apply mistake proofing, you will end up with a lower RPN. Where you don't, you'll end up with a higher RPN. And again, there's a logic flow left to right as you go through the template. So now I'm going to hand over to Steve, and Steve's going to take us through the how we manage human error within an assembly PFMEA. Bearing in mind that our operations are very manually intensive and reliant very much on people. Steve?
Yeah, thanks, Ian. And like Ian mentioned earlier, we did do a webinar topic on this last year, which obviously goes into a bit more detail, but we just wanted to cover the key points, linking it to an assembly PFMEA. Again, like we've already mentioned, from an aero assembly operation perspective, we're putting together and inspecting 30,000 components in around 6,000 manual operations. So there's a lot of opportunity for errors, and human factors therefore plays a critical part for assuring we get the right product quality and product safety. That's why, from a human factors point of view, we've looked at risks in a PFMEA perspective and how can we help reduce those risks as we do the assembly operations. So within Rolls-Royce, we use the dirty dozen, which are the 12 most common causes of human error. And hopefully, some of you on the call are aware of the dirty dozen and human factors. And obviously, it's part of the AS13100 standard as well. What I want to do now is just talk a bit about distractions, and we'll move on to the next poll. What we found when we was looking at the human factors and the risks around our operations and inspection activity, distractions was a big cause of errors and obviously a big risk to us. So wanted to do a bit of a poll on that. If you think about distractions in your workplace, what do you think the biggest cause of distraction is in your area? A few examples there that we've pulled out. Just launched the poll. As you can see, there's quite a lot of different things that could cause a distraction. Just be interested to see what people think around that. Looks like we've got quite a high percentage on just talking with co-workers can be a distraction. If you're doing a critical operation or a piece of work and somebody interrupts you, that can stop you in your flow and that can cause a distraction. Using personal telephones, again, looks like it's quite high. Interruptions by management or supervisor, that's around 12% at the minute. Poor part quality, too much paperwork, again, those can be quality issues that cause you to stop, again, which causes a distraction. So yeah,
and that's fairly consistent with what we've seen as well, Steve, isn't it, from the work we've done on the shop floor?
Yeah, definitely. And again, it's very difficult to reduce distractions to zero, but there are things you can put in place to obviously reduce it as low as practical, really. So one of the frequently asked questions we had on a previous webinar was, why don't you have the human factors FMEA into the part-specific process FMEA as per the RM13004? So I just want to touch on that in a couple of slides to try and bring that to life. So this is an example of a process FMEA. where we've put the human factor as fatigue as the failure mode. Now, as we've discussed earlier, fatigue is not a product failure mode. So failure modes in an RM13004 PFMEA should describe the product non-conformance or product requirements. So this shouldn't be put in as a failure mode in the process FMEA. The second example is just to try and bring to life where we've used a human factor as a potential cause of the failure mode. So the failure mode is the parts fitted in the incorrect orientation, and then the potential cause is a distraction. So what we must try and avoid is obviously simple operator error as a potential cause. If we removed the distraction, could we still fit the part in the incorrect orientation? That's what we need to ask ourselves. Is there a cause and effect relationship?
And I guess, Steve, it's putting it the other way around too. That cause and effect of relationship. If an operator was distracted, would he fit the part in the incorrect orientation? Yeah. That link is quite weak. So, as Steve said, we are looking to say, well, if this cause was to happen, you would want a much more direct. If this happened in the process, this is what would happen in the product, and that link is very weak on using it in this way. Yeah,
definitely. So obviously human factors aren't related to specific part non-conformance. So the way we've done it is look more at the working environment and looked at those human factors from a process or environment point of view, from a manufacturing or an inspection area. So we've taken a slightly different approach and taken those human factors risks out of the process FMEA. So some of the key insights really, we believe putting human factors risks into the product FMEA can create too much noise, a bit like Harj mentioned earlier around the old way of doing FMEA, using every single process step. It can create a really big document and a really big FMEA. So we decided to do a separate human factor FMEA approach, and just do a high level analysis of each process or environment in a certain area. So we've rolled that out across the assembly and test operations. So we've done assembly operations, we've done inspection operations, test operations, and transactional operations as well. So we've done a range of different processes. In the human factors FMEA, we use the dirty dozen as the failure mode, because obviously we're not doing a product FMEA, so we use those as the failure modes. And you'll see examples on the AESQ website and in the guidance material, an example of the human factors FMEA that we've shared with the AESQ. The interesting point is when we go into different areas, each area will have a unique signature based on its environment. And obviously that can change over time, so it's important, we revisit these FMEAs because things do change. You might have new people coming into an area, you might have a ramp up in workload, so there might be more pressure. We could have a number of quality issues in the area which might lead to a distraction, for example. So these human factor issues can change on a regular basis, so it's important we update and keep them updated on a regular basis. The positive from a Rolls-Royce point of view, this has improved our human factors awareness and just culture. So where we have deployed these human factor FMEAs, we've seen a lot better numbers regarding issue reporting and improvements related to human factors where we've deployed this. So we've definitely seen it as a positive over the last 18 months where we've been rolling out this process. And I think it's helped us reduce the amount of errors we're getting and obviously the amount of escapes we're having to the customer. So we are seeing benefits now in our KPIs and performance from a quality point of view.
Thanks, Steve. And certainly I think it gives a structure to a really value-added discussion with the teams who work in that area. Certainly on the shop floor, I think the biggest feedback was let's just stop management and supervisors coming on the shop floor and distracting them. But beyond that, there's some really useful insights that have come out, and there are things we can do to address a number of human factors really simply and easily. And as Steve said, if you go onto the AESQ website, there's a webinar with some more detail and some other materials that kind of shares that approach that we've taken in Rolls-Royce. Okay, so we're going to continue, and I'm going to hand back to Harj to kind of give us a summary of those key assemblies insights.
So 4 things we want you to take away when implementing the RM13004 assembly PFMEA. So again, as we discussed before, the requirements have to describe the physical product outcome of what you want to achieve. So like we showed previous, where we had the assembly instruction, we only showed the product related descriptions in that assembly instruction. And again, as we discussed, it will greatly reduce your PFMEAs from the hundreds to the 1,000 lines. So again, you're keeping it product focused. Failure mode, so again, it must describe a physical property of the product, and these are derived from the requirements description. So like we showed in the live demonstration, like Ian discussed, use the standard failure mode checklist. And again, there will be other failure modes incorporated in there, but this is just a good starting point for you to use. And potential causes of failure, so again, try to avoid completely like operator error and that. And again, like Steve discussed, use the human factors PFMEA approach if you feel this is a problem. And the biggest one for me is potential causes of failure. So it is, for me as an ME, I sit on the shop floor with the fitters, and it has a vast amount of benefits from doing this. So not only does it build a great relationship up with the fitters, and it gets you well acquainted to your product, it also helps to keep the PFMEA alive, and it strengthens your potential causes of failure up because you're actually going to the people who do the job. So it's good to capture their insights and take on board their suggested improvements. And here we've got some examples of that practice in place. So again, you see myself going up to the fitters, having my standard failure mode, and again, speaking with them, getting their insight, and really strengthening up them causes of failures. And to the right hand side, what we've got here is in each area we have an action tracker. So on a daily basis, we have all the PFMEA recommended actions on this board along with improvements. So we have a cross-functional team that comes from different areas, and we strive to drive down high RPNs and just implement them improvements. The reason why we do it on the shop floor is, one, I deem it better because we're next to the fitters, and again, we can pull the fitters in. We can pull the fitters in when required, so they can give their feedback. We feel this approach really works, and we've been seeing some great results from doing this. So again, it's just a little bit of an example of how you can extend on the PFMEA approach by burning down them high RPNs. So thank you very much. And with that,
thanks, Harj.
Pass it back to Steve.
Okay, so now we're going to go on to questions, and hopefully if Steve's been keeping an eye on the chat function, we'll be able to collate those into some questions, and hopefully we can answer.
Yeah, it looks like there's been a lot of activity in the chat, and obviously people have been interacting with each other, which is great. So if you just give me a second just to scroll through a lot of the questions in the chat. Okay.
Well, while you're doing that, I just want to build on Harj's point. Clearly, when you're doing a process FMEA, if we were doing it, as we said earlier, at the right time in the APQP process, we haven't necessarily got any hardware around for that product. You know, we're kind of looking at drawings and designs and proposals, etc. But it's been amazing, I think, that when we've gone down, even though there's like 5 or 6 engine types in Derby currently in production, when we start talking about new major modifications or new engine programs coming through, the basic principles of how to put an aero engine together are largely the same. So taking that experience of existing engines and asking the fitters, what would you change about it so we can't get it wrong, or we make it access easier to get the tooling in to do this operation. We've had some absolutely fantastic inputs from the operators. And I think one of their frustrations has always been the amount of processes we've ended up with, where if only we had talked to them earlier, they could have said, well, if you designed it like this, or if you designed the tooling like that, then this would have addressed this major issue and it would have reduced damage, or it would have reduced our non-conformance. So what we've found is, we have people that have worked in Rolls-Royce on engines for 20, 30 years. The amount of experience they've got using the FMEA template, using that structure to have a conversation around it, really helps to capture it. The FMEA is almost like a knowledge management hub. Everything we know on how to assemble an engine is captured in that FMEA, but it really does require all the right voices to be involved in it. So, whether you're a fitter, an ME, a design engineer, a quality engineer, it's making sure you've got all of that insight captured in the FMEA, and it really is in my view, one of the most powerful tools we've got to try and avoid defects going forward. And from a zero defects point of view, clearly you only get the benefit where you apply it, but it is by far one of the most powerful tools if you use it with the right intent. And as you can see in the picture with Harj, if you're actually using the output of it to drive down the improvements, then absolutely it is a fantastic tool, and it has transformed, I think, how we think about putting aero engines together over the last few years. Steve, has that bought you enough time to ask me a question?
Yeah, thanks. And like I said, there's quite a few comments and questions in the chat, so we'll try and answer as many as we can. But I think what we will do, if we do miss a few of the questions, we'll go through afterwards and make sure we do a bit of an FAQ and put that on the AESQ website. So first question, I think this is going back to when we was talking about the sort of product requirements on the PFMEA. So where we mentioned every design characteristic, does that mean that every feature on the drawing, for example, should be considered?
Yeah, so absolutely. And I think one of the key things when we put together 13100 and RM13004, we saw it as a key enabler to our zero defects journey. And to describe it simply, if we really fundamentally believe in what FMEA can give us, and hopefully you've seen some of that insight today in terms of having the conversations that lead you to how do you prevent these things from happening, you only get the benefit where you apply it. One of the mistakes I think we used in Rolls-Royce sort of 10, 15 years ago is we convinced ourselves we knew what was important and what wasn't important, and we applied FMEA to key characteristics or customer characteristics, and we didn't apply it to all features. And what we found is, well, actually, when you do the analysis of the things that went wrong in the process or the things that escaped Rolls-Royce and impacted the customer, they all tended to be, none of them were key characteristics. None of them were those things where we'd applied the tools, whether that's FMEA or gauge R&R or SPC. All of those things used to be focused on key characteristics only. And clearly then the conclusion we got from that is, well, if you apply the key characteristics and those aren't the things that escape, it must be working. So as part of our zero defects journey, which we launched in 2016, the natural progression was, well, okay, in that case, if you really believe in zero defects as a goal, we need to take the same approach on anything, so that, you know, we give the same level of rigor to all of those features. So absolutely, one of the things we wrote into the standard was, if you're doing an FMEA on a machined part and there's 500 features on that part, then you need to consider each of those and do your own risk assessment. It's one of those ironies that I think people will argue, well, I know what's important, and therefore I'll do FMEA on the things I think are important. Actually, the FMEA process, because it's a risk assessment, it's the FMEA process that tells you what is important. You know, design will look at it through a certain lens and categorize certain things as key characteristics through that lens, through a performance route. But actually, there are things in the process that could take a feature that otherwise, as far as design is concerned, is quite benign. But if we got it so wrong in manufacturing, it can actually turn into something really significant. So yeah, the intent is we do everything. Part of our issue was, I think, is when you have 5 or 6 products with 30,000 components and 6,000 operations already in place, it can be really daunting to say, well, hang on, we're going to have to retrospectively go back and do all of this. So we did put some rules around. So for existing products, we said if we make any changes, if there's any source changes, design or process changes, we will apply FMEAs to that. All new products that get introduced, we will start off by applying it 100% to all features. So, you know, it was about how we got the organization to have the capability to be able to deploy this on all features was really important. And we recognize, you know, particularly if you're a supplier to Rolls-Royce, in a lot of cases you need engineering support from Rolls-Royce to actually complete the FMEA or to have an input into the FMEA, to do the severity and the effects, etc. So, but certainly that's the intent of 13004 and 13100, is that we apply it to everything to get that maximum benefit as part of a zero defects journey.
Thanks, Ian. That sort of leads on to the next question. Talking about suppliers, they may not know what the end use of the product is or the real effect of the feature failure mode. So they're only able to identify the effect internally, such as scrap or rework. How can they improve this?
Yeah, and look, you know, as a aero engine manufacturer, we recognise, and as part of AESQ, I think it's a common issue amongst us all, that you will need input from our design teams to help you with that. But also, I don't think it's, you know, so if you're sitting there thinking, oh yeah, well, I haven't got a Rolls-Royce design engineer as part of my team, therefore I can't do a process FMEA, that's not quite right either. Because it's amazing with all of the experience of the supplier has about when things have gone wrong previously. Crikey, this ended up causing an in-flight shutdown, or this problem ended up causing a problem to Rolls-Royce that stopped their production line, and we had to rework everything. So I think there is more tacit knowledge in a supplier than sometimes they may give themselves credit for. But you're absolutely right. I think the issue we've got to overcome, and the elephant in the room, is we have a finite resource that we can't put people into the suppliers organization for long periods of time to work on FMEAs. But what you can do, and the way we found it works the best, is if a supplier comes to us with a completed FMEA and says, look, I just need you to look through these failure modes, and have we missed anything from a potential effect, or can you help us with the scoring? if you have that already prepared, it's that much easier for our design teams to get involved and have an input to help you make sure that you haven't missed anything, and that if there is anything significant in there that could lead to a product safety issue, they can actually help inform that. So there are ways around it. I'm not saying it's easy. It's one of the biggest challenges when we launched our zero defects program in 2016 to our external supply chain, as well as internally within Rolls-Royce. It has been a continuous feedback from our suppliers to say, look, we need more support from your engineering function as well. So we are still working at making sure we can do that. But there are things that the supplier can do to help us with that. And the other thing I should point out is, these standards, although they're kind of deployed through 13100, within Rolls-Royce, within Pratt & Whitney, within GE, we are working to RM13004, 13003. These are things that we are deploying ourselves, and we are gathering experience and coming across a lot of those same issues too. So this isn't just something we are cascading down into our supply chain. It's something we are challenging ourselves to meet this standard as well. Okay.
Thanks, Ian. We've had a couple of questions in the chat around can we receive a copy of the slides and can we receive a recording? So like Amanda mentioned at the start, these will be made available via email to all the attendees, and obviously there'll be a link posted on the AESQ website afterwards.
Yeah, and just to build on that, so Amanda is recording. Hopefully she's going to edit out the bits that where I wasn't, I was on mute for 5 minutes, but it will be made available pretty quickly, but also the copy of the slides will be made available on the website as well, hopefully tomorrow or certainly in the next couple of days, for you to be able to download and use that. And I'll come on to it in a moment too. I really would encourage, if there are any questions, any follow-up post today's event, please get in touch. I will share with you the best way to get in touch with us. But we want to keep the dialogue going, because although we are sharing something that we've learned today, we are keen to learn from anyone else who's been deploying this in their business and what's worked, what people are struggling with, and let's keep the discussion going.
Yeah, I've got a couple of questions on the human factors FMEA, so I don't mind answering these. When rolling out human factors across our company, should we be completing human factors FMEA in all areas from goods into dispatch? It's probably good practice. I don't think that is a mandatory thing to do, but certainly the approach that we took was broke down the areas and the processes into a value stream, thought about maybe where the high risk processes were from a human factors point of view, and then sort of prioritise the ones that we thought were highest risk, and then worked our way backwards. So yes, it's good practice to do that. I don't think the standards say you must cover all areas, but definitely good practice to assess each area and see what those risks are, and then obviously put the improvements in to try and reduce some of those risks.
Yeah, and to Steve's point, it's certainly not a mandated requirement of 13100 to do human factors FMEAs. It's something we shared because we got benefit from it on two fronts. One, it kind of helped us to explain why we weren't putting all of these operator error, human factors things in our product FMEAs. So it helped kind of that discussion. But also, we know in such a manual environment, human factors play such a key role in, did we have a good day, bad day? How are people feeling? Are they fatigued? Was there a correlation between the amount of defects we see on night shift versus day shift? Night shift is great because you don't get all the managers and the supervisors walking around and distracting you. But actually, it takes a while to adjust to that. And as Steve said, look, we started looking at some of the areas that we felt were more prone to human factors being an issue. So we started very much at the end of the line in our customer dispatch area, where there's always a lorry waiting outside for that engine, and any delays can cause a lot of pressure and very quickly becomes visible to management. So we knew there was a lot of different human factors that were impacting that area, and that's one of the first areas Steve started, that we knew was a hot spot, and that really gave us some insight in terms of what did we have to do to create an environment that allowed the people working in that customer dispatch area to get on with the job, to not be distracted, and to be at their best for longer. So yeah, like with all things, I think ideally, yeah, you want to do it everywhere. But today, where are you going to start, and how are you going to work through that deployment? And what we found is once we did it in the customer dispatch area, and we were able to show the benefits and the things that came out of it, all of a sudden more hands were going up across the business saying, "Oh, I want to do that in my area because I think we've got some issues." And so it's creating that pull from the organisation when they actually realise what benefits you can get from these approaches.
Thanks, Ian. Question to Harj, I think, on this one. Do you use any particular software packages to manage your PFMEA documents?
Yeah, so we use a software package from Reliasoft called XFMEA. So it's got great benefits. So not only is it a central repository where we can access all FMEAs and it's revision controlled, but it has some good features where we can prioritize high RPNs. So it produces all the graphs and the dashboard for you straight out of the software. And again, it has that cross compatibility between Excel and XFMEA. So yeah, it's a good bit of software that we use. And again, it just helps all keep control of all the documents.
And it's one of the questions we get asked a lot. And later on, I'll show in terms of a future webinar around FMEA software is in the planning stage and will be made available shortly. What I would say with XFMEA, that's the key tool we use across all of Rolls-Royce. It's one of those things that is quite flexible. Now, it requires, I think, a bit of programming knowledge to get the best out of it. But if you imagine you can create control plans from the FMEAs quite easily. So once you've done all of that work up front, there's a huge amount of information you can reuse, and XFMEA allows you to do that.
Yeah.
But clearly there's other packages out there that can do the same. And again, particularly those developed in automotive sort of 20, 30 years ago, a lot of those integrated systems will do the same.
And just one thing to add as well with XFMEA. So when we have a recommended action put in, we can assign that task to a certain individual and it will send them a notification that there's a task assigned to them. So just another feature of XFMEA.
Okay.
Probably got time for a couple more questions,
Yeah,
I think.
okay.
Probably one for Ian and Harj. How can we increase cross-functional engagement in our PFMEA sessions?
Yeah, well, I think that is absolutely crucial. So one of the things I'd say in Rolls-Royce, we had an established way of actually FMEAs were for manufacturing engineers, and I'm kind of exaggerating a little bit, but it was kind of, well, nobody else understands FMEAs apart from us manufacturing engineers, so we'll just get on with it and do it. And when we launched our zero defects program, we noticed that, well, actually, there are things that the quality function, for example, could bring into that discussion, whether it's defect rates, and we were sitting on a lot of data that the FMEA team weren't aware of, maybe some of the customer escape issues we'd had over the years, etc. But there is an important point is it's okay saying we want to be cross-functional and all ME had to do was start sending invites to the quality function or the operations function. One of the first steps is we had to train the quality, the operations functions, the design community in FMEA. So when they turned up to these meetings, they actually knew what the process was and what we're trying to achieve, but also they understood what their contribution to that was going to be. So there is a bit of work to do up front to make it effective, and we don't just have people sitting quietly around the table, not really understanding what's going on and not really knowing how they contribute to that. So, but I think what you will see very quickly, and I was lucky to be in a number of sessions in Rolls-Royce when we had a true cross-functional team come together for the first time, using the structure of the FMEA, the debates that come from that, very quickly showed the power of having those different functions around the table. And I'm sure if you were to do that in your area very quickly, the value that you get from a cross-functional approach will be realised.
Yeah, and I think where we did the human factors FMEA again, a cross-functional team was used, and it was really beneficial. To aid some of the discussions we're having throughout the team.
Yeah.
I
just build on that, and without giving too many Rolls-Royce secrets away, I think that there is a perception at times that ME might think the world works like this, and then when you talk to the fitters and the operators on the shop floor, they tell you that actually that's not their view of the world. So the structure of the FMEA to bring an ME and a fitter together and a quality person, actually there's a lot of times where there's a real misunderstanding about what really happens as opposed to what is supposed to happen when you just read the instructions. So from an ME point of view, it is really powerful to hear the voice of the fitter telling you what is it like actually to fit that clip stack or that pipe or whatever in the way it's been designed and the problems are given. Because an ME looking at a 3D model and looking at a work instruction, it all seems as if it should be fine. It's the insight you get by involving the others. That's where the teams really start to get the benefit of having all the right voices in the room at the time talking around it. And the FMEA approach, that structure, allows that discussion to develop. Okay.
Yes, probably just have one more question because I know we've got a few more slides to get through. So the last one is PFMEA more for new products as opposed to legacy products? Should it be implemented for legacy products?
Yeah, that's a great question. I mean, if you were to take it in its purest form, you would do Process FMEA. It's a part of advanced product quality planning. You would do it, and it's more powerful when you do it, as we said earlier, and you start looking at your process design at the same time as you're looking at your product design. That's where you can start having feedback with design about how you mistake-proof things and how you design products that go together really easily. Your design for assembly work happens. Unfortunately, and Rolls-Royce is in this position too, we have a number of products around us that didn't go through that rigor during new product introduction. So when we launched Zero Defects in 2016, we knew the only way we can get to zero defects is by going back and challenging a lot of that NPI stuff and retrospectively doing FMEAs and gauge R&Rs, etc. The realization, though, was that is a huge beast. So where we came to, and I think where a lot of companies come to, is for legacy products, we aren't committing to go back and apply this to everything on a legacy product, but If the product changes, then we will apply APQP to those parts of change. If the process changes or if the source changes, so we've moved an engine assembly from Singapore to Derby in the last few years, there are some triggers that will cause you to say, right, okay, I'm going to use APQP to control this change. So as part of that, we are deploying FMEA to those changes. We also know where we've got a major quality issue, that could be another catalyst for, yeah, actually when we fix this issue, we're going to go back and we've identified a process that's caused us a problem. We're going to take that and apply FMEA or gauge R&R or SPC and redo it as if it was going through APQP for the first time. Clearly, sometimes you're limited because if it highlights a design change, that can be really costly and might limit to exactly what you can do on legacy programs. Having said that, you know, there's loads of examples in Rolls-Royce and our supply chain where they've applied FMEA on legacy products and made some fantastic changes that have made a step change in quality performance too.
Thanks for that, Ian. Yeah, just thanks everybody for the questions. We've got probably too many to answer during this webinar, but like I say, we'll take those away and go through them and get those published with the presentation and the video. And thanks for obviously a lot of people interacting with each other as well, which is great. So yeah, thank you for that.
Okay, thanks, Steve. Thanks, everybody. So there's just a few more slides to finish off today. So clearly we've talked about process FMEAs as described in RM13004 and AS13100 through the lens of a complex assembly environment. But there are other ways to get more information on this topic. So I've mentioned, there is a reference manual, which is free of charge to download from AESQ website. And you can see the address at the bottom here. There's a subject matter interest group, and what that is, the AESQ is made up of a number of different aerospace companies. So you have GE, Pratt & Whitney, Safran, Rolls-Royce, but also companies like GKN, Honeywell, MTU, Howmet, and what they've done is set up for each of the key topics in AS13100. We put our subject matter experts into something called a subject matter interest group, really to develop materials to help companies deploy AS13100 and in particular some of these topics. Now, you can contact the subject matter interest group through the AESQ website, asking any questions or how to get more involved or an interpretation maybe of AS13100 requirements. We also have a community of practice, which is on LinkedIn. So there is a 13004 community that is open to everybody to join it. And again, it's a way of asking questions, it's a way of sharing good practice, it's a way of getting clarification on something. So for instance, the topic of software that different companies use comes up a lot. So that is open to anybody. You don't have to be an aerospace engine supplier. You don't have to be in aerospace. You can join that and get involved with the discussion. And beyond RM13004, that's just one of a number of standards to support the AESQ 13100. You can see here in the red text, there's a number of other subject matter interest groups and reference manuals. So everything from problem solving, MSA, quality audit, human factors, APQP and PPAP. So if you were involved in deploying any of those in your company, then again, there's a reference manual that's free to download. There are company experts that you have access to get any clarification or to get some guidance from. Okay, next, I just wanted to remind everybody that if you go on the AESQ website, and again, I've included the link in the QR code, but there are 6 related webinars recorded on there that you can download, watch for free. And for many of them, the actual, again, the presentation slides are available on the website too for you to download. So there's ones on a broad overview of Process FMEA. We've got ones on control plans, design FMEAs, and human factor FMEAs as well. So those are all there for anybody to download, again, free of charge. There is one that's in planning, and we are hoping in the next, certainly by sort of April time-ish, will be scheduled, which is one around FMEA software and user insights. So we have Ebru from MTU and Jonas from Rolls-Royce are currently preparing some examples of the types of software that we are using in our own company. So as Harj says, we use XFMEA in Rolls-Royce. MTU use a different integrated software. They are going to share their experience with those software. So again, if there's any particular questions you have around that, then you can contact through the community of practice on LinkedIn to make sure that they take account of that when they're developing their webinar. On the left-hand side, on the AESQ website, there is an events page which will show you what's planned and the dates and give you links so that you can register. It's worth keeping an eye on that because there's a number of webinars planned for this year, which I think is my final slide. So this is what the events page looks like at the moment. And you can see there's a number of things here. In particular, the process control subject matter interest group. Almost every month I've got a different particular topic around process control that they're running a webinar on. So it really is a great resource. They're all free. They support the deployment of 30100 and the relevant reference manual. So you will undoubtedly see things that in the future may be of interest. And there's also listed on here things like supplier forums, where you can actually go meet the team. So you can see a picture along the top of that header there. That's from a supplier forum we did in Toulouse back in 2019. But it's a great opportunity to go and actually meet the people who are writing the standards or writing the reference manual and to get involved and give your feedback. So again, the supplier forums are free. They do rotate every quarter. So there'll be there's one in Tokyo coming up in April, then there's one in Sweden in Trollhättan for June. So again, keep an eye on those. The AESQ do an absolutely fantastic job, I think, of making information available and giving all companies access to the people who are defining the standards or are deploying the standards through their organizations to their supply chain. So with that, again, to Steve's point, I just want to thank everybody, A, for joining, B, for getting involved and asking loads of great questions and taking part in the polls. We really do hope you found it interesting. And again, we are keen to find out, is there any other topics that you would like more information on? And if there are, if there's anything, any themes that are starting to come through, we will use that to help us plan for the next webinars or the next inclusion in the reference manual and material we can make available on the AESQ. So that's supposed to be from Amanda, Steve, Harj and myself. Thank you very, very much. We hope you found it interesting and we hope to speak to you again soon at one of those future events. Thank you and goodbye. Thanks, Amanda. Hello, everybody, and welcome to this